Okay, here goes number 9. Now, on the last couple of questions that we covered, the thing that you have two things to look out for. Okay, so check if you have one log only, so log whatever something here equals just plain no log here. Okay, so in this case, you have to change this one to exponential expression or exponential equation. Change it to exponential version of it. So for instance, you have this log 5 x equals 3. So you have to change this one to 5 to the 3 equals x. In this case, you only have log 5 on one side of the equation. That's one way. Now, the second one, which is like number 8, in 7, you have log 5 x plus 2 here equals log 5 3x something something. So in this case, you would notice you have log 5 on one side of the equation, but also another log 5 on the other side of the equation. In here, you only have one log on the left side of the equation. It could be right side or left side. As long as there's just only one log, you change it into exponential. In here, if they have the both, in letter B, if you have both log 5s, then that's when you cancel out the log 5s and you do x plus 2 equals 3x, right? So that's how you solve that. That's pretty easy now. Now, but on number 3, example number 9, this is a little bit different because it's like log 5. This is just an example, not number 5, all right? Log 5 x equals log 5, let's say 2 plus log 5 x plus 2x. Let's do 2x, okay? All right, so in that case, well, let's look. On the left side of the equal sign, you have one log. But on the other side, you have two logs. So in order for you to be able to cancel them, these two should be combined into one log 5, okay? Because you have two expressions there. You have log 5 here and you have log 5 them. They need to be combined into one log so that you can revert back to solution letter B, like similar to letter B, okay? So let's review things if they are in expanded form, like you have multiple logs in one side of the equal sign. All right, so first thing, let's review. One is if you have log 5 x plus 2. Oh, that's not a good example. Okay, so log 5 x y. So this is in between example number 1. Okay, in between, your argument has two values, x times y. You're multiplying that. So therefore, we can expand this by making it log 5x plus log 5 y, because that's a multiplication. Okay, so therefore, if I give you 3, then you just add. This is 2xy, then you just make this one, okay, you have 3 things that you multiplied, and they'll just be log 5 2 plus log 5x plus log 5y. So that's the expanded form. Now, why am I talking about this? Because in number 9, you have an expanded form. So you have to go back, make it unexpanded, which is compressed. I don't know if that's the correct word, but basically combine them into one log. Okay, so this is what you do when you are multiplying. They are added. Okay, so let's do an example for this one. Let's say I give you log 2 3, okay, plus, so I'm gonna give you the expanded form and you to give me the compressed format. Okay, so log 2 x plus log 2 maybe m. Okay, all right, so if you have that, first check if they're both log base 2. If they're not base 2, then you can't really combine them. Okay, well, you can combine them but in another way, but not in the with respect to this type of problem. Okay, so they're both log 2s, and then also it's all addition in between them. So that means all these 3 arguments can be multiplied. Okay, so this one therefore is equal to log 2. That's log 2, and then all the arguments will be multiplied, 3xm. So from expanded, you make it compressed, and so now you only had one log 2 to work with. Okay, that's one example when you have multiplication in between. Now let's do a second example. okay, where you have division, okay? So let's do log 5 x over y. So this is x. In fact, I'm going to do 2x over y, okay? So in the numerator, you have two things. You're multiplying things in the numerator, so that means that's multiplication on top of them. But with the y, it's a division. So therefore, division becomes a subtraction when you expand it. So in this case, this will become log 2 for that one. And then you have x, both of them are in the numerator, so they're both positive. So log 2x. All right, so 2 and x are in the numerator. So this is, in fact, in front of this log 2, that's a positive one. In fact, in front of log 2x, that's also positive. So that's what I'm talking about. If they're both in the numerator, they're both positive. Now the y is in the denominator, so this will be minus log 2y. Okay. So let's do an example, a little bit similar to this. Log 3, we will expand it first. Let's say m squared over x. Okay, so you only have one expression on the numerator, not a factor. It's just an m squared. And then in the denominator, you have x. So therefore, the top is a plus. This one is a minus. So that will be log 3 m squared. And this is going to be minus log 3x. Okay, so now let's do something similar to what we're going to be doing on number 9. Let's say I give you log 4 xy minus log 4 m. Yeah, let's do that. Okay, so these are two logs and there's a subtraction in the between. So therefore you can combine them by copying your log 4. But since there's a subtraction in between, then that must mean xy on top, this one here on top, and then this one here in the denominator. So that will become that will be the compressed version of that example. Okay, so I'm gonna make an example problem similar to this. Okay, so let's say log 4 3x equals log 4 5 plus log 4 2x plus 2. Okay, now equal sign, let's check how many logs. You only have one log here, that's great, but this one here you have 2, so therefore you need to combine them, right? Now there's a plus in between, so when you combine them, that must be a multiplication. All right, so let's do that. So you have log 4 3x equals, copy log 4. Now this is the plus, so that means you're multiplying this with that. Okay, so that's gonna be 5 times 2x plus 2. Okay, now let's simplify this. Well, I guess you can keep it that way. Now, all right, so really what we want is to solve for x. So now in here on the first problem, you only have one log, you have 2 logs. Now you have one log. So therefore that means your arguments must be equal. So we can now say 3x equals 5, 2x plus 2. Okay, distribute this, copy 3x here. 3x here equals 10x plus 10. Okay, minus 10x minus 10x. So you have negative 7x equals 10 divided by negative 7, x equals negative 10 over 7. Now again, you have an x that is a negative. Of course, I just made this one up, so that's why the numbers are a little bit difficult. All right, I just made this one up. Again, if you have a negative number, you may want to like substitute that into your x here and see if it's actually a correct, something that will not give you an error, just like what I mentioned in the first video, okay? All right, so that's what you do. In fact, I'm gonna get you started on this one, okay? So I'm gonna copy this, log 3, 2x equals log 3, 2 plus log 3. And feel free to just pause me if you want to try it on your own, and then you can double check your work, right? Okay, 1 log 3, 2 log 3. So therefore, we need to combine this. That's a plus, so that's going to be a multiplication. So now you can say log 3, 2x equals log 3. Now we will combine them. 2 times 3x minus 1. Okay, so now you both have one log 3 each. So therefore, you can equate your argument. So this one right here will be equal to all of that, and so you can just solve it. All right, so that's an example number 9. Let's move on to example number 10. Okay, example number 10, it's pretty similar, right? Okay, so you have, in this case, the only difference is that you don't see the base. That means it's 10, right? So that's base 10. Okay, so I'm going to give you another example like this. Okay, so log 3x plus 2 equals log 2 plus, do I want to, okay, so log 2 plus log 20 maybe. Okay, so now you 1 log here, 2 logs here, you need to combine this. That's a plus, so you have to multiply. So therefore, we can just rewrite this part, log 3x plus 2 equals log, and then you combine this 2 with an addition. That means you have to multiply them times 20. So now you have log 3x plus 2 equals log 40. Okay, now they both have log here, so therefore you can just get rid of them. So now you can say that 3x plus 2 equals 40, and then you can just solve for the problem. Okay, all right. The next couple of videos will be on a different video, I guess. All right, I'll see you.